Hi, my name is Brian. Welcome to another video on derivatives. In this video, we're going to do another example of related rates. In fact, this is part B of our rocket ship problem. So if you haven't seen part A, go check that out right now. All right, so without further ado, let me read the problem. Television camera is positioned 1,000 feet from the base of a rocket launching pad. The angle of elevation of the camera has to change at the correct time in order to keep the rocket ship in sight. Let's assume the rocket rises vertically at 500 feet per second when it has risen 2,000 feet. Now part A was how fast is the distance from the television camera to the rocket changing at that moment, and we have done that in part A of the rocket ship problem, so again, go check that out. Part B is if the television camera is always kept aimed at the rocket, how fast is the camera's angle of elevation changing at that moment. All right, so let's move that out of the way. It's a very long word problem. So step 1 and step 2 are about writing down all the information from that word problem and then drawing a picture as well. So let's go ahead and do that. We have our camera, which is right there, and it is 1,000 feet from our rocket launching pad. So we'll say that's right there. Now the rocket's going up vertically. So we have that. Little person in there. There we go. And it's rising at 500 feet per second. So let's call that y. So that will be the distance the rocket's traveled vertically. So that means I know dy dt is 500. Now in part A, I wanted to know how fast is this line increasing as the rocket goes up. But for this video, we are talking about theta. How fast is this angle increasing as the rocket ship goes up? Now in this video, I want to know what d theta dt is when y is 2,000 feet. So part 3 of our steps, how do we relate the variables y and theta together? Now I do have a right triangle, so we try Pythagorean's theorem, but that's not going to help us because this has a theta in it. So instead we're going to do SOHCAHTOA. We're going to relate the sides of a triangle with its angle. All right, so we have an opposite angle and adjacent angle. So of the SOHCAHTOA, we're going to use the TOA, the tangent. So let's write that down as our formula. So we know that tangent of theta is going to be y over 1,000. Next, we're going to have to differentiate both sides. Sorry for the squeaks. So differentiate both sides. So we're going to take the derivative of tangent with respect to t, and then we'll do d dt of the right-hand side. Now the way it's written right now, it'd be easier to write it as 1 over 1,000 y. All right, so let's differentiate tangent. Since theta is inside tangent, we got to deal with tangent first. The derivative is going to be secant squared theta. Now we have to differentiate theta, because that's what's inside, and that's going to be d theta dt. On the right-hand side, I have to differentiate 1 over 1,000 y, which is just going to be 1 over 1,000 times, well, the derivative of y is just going to be dy dt. Okay, now that I've taken the derivative, let's figure out what we need. I am trying to solve for this d theta dt right here. So that's what I want. So let's go ahead and divide the secant squared over to the other side. So that's going to be 1 over 1,000 dy dt all over secant squared of theta. Now we just have to plug in the specific information from the word problem. Now we know dy dt, let's go over here. We know that dy dt is 500, so we have that. But we don't know what secant theta is. Okay. The easiest way of doing that is to complete the triangle, because now I know that the height, the rocket is 2,000, and that's going to be 1,000. If we can complete the triangle and get the hypotenuse, then we're going to be able to do secant theta, because now we'll have all the sides of the triangle. So to get this right here, it's going to be the 1,000 squared plus the 2,000 squared, this is Pythagorean's theorem, is going to be the hypotenuse squared. Now, if you solve for that, you are going to get 2,236.07 for the hypotenuse. So then what is secant theta? Well, secant theta is going to be the hypotenuse over the adjacent. So let's erase the question mark now. And we're going to say that's 2,036.07 divided by 1,000. Now that's just secant theta. So then in order to get secant squared, we're just going to have to square that number. All right, so let's go ahead and plug in all our information here. We have 1 over 1,000. We have the dy dt, which is 500. And on the bottom, we're going to have that big number over there, the 2,236.07 divided by 1,000, all squared. All right, grab my calculator here. So I'm just going to evaluate this. 1 over 1,000 times 500. And we're going to divide by that big number here. So it looks like our final answer is going to be well, we're going to round, so it's actually just going to be 0.1. Now we're talking about d theta dt, and so this is all in radians. So this is going to be radians per second. All right, so that's the end of this problem. I hope it helps. Again, check out part A if you didn't do that one already. Anyways, good luck. Bye.